cross sections perpendicular. Now, the textbook work, I didn't make it due last week because my priority was you guys studying for your test and getting your tests done.
Oh wait, but 5.6 was due, right?
Yes, that's all that was, the textbook up there. Same thing with you only had, did I have a My Math Lab for anything in 6.1?
Yes, or yes, you did for 6.1.
Just six, that was only it was only after the first set or after the second set?
I think.
I don't remember. Either way, I have to add to, you're going to have some My Math Lab problems, a couple. I think I only gave you 3 or 4 questions on cross sections because they take time, to build those cross sections and figure out it's not a piece of cake. So there's your part 1. And then you had these practice problems, which I sent you. I think I sent you a video of all the solutions of those. And I did it with my cats. They enjoyed it. I lectured the disc method. Those were fun. And yes, I remember getting through those. Then I don't think I did these with you. These were like more extra practice. After the lecture, I added those. Those would be like problems I could have given you for homework, but I stuck them in there just for more practice. And if you worked on them and have a question, I do like what the book does in the sense that it gives you that pink line of what axis it's rotating, because then it's obvious that we're talking about a dx being the thickness, and that obviously you're rotating this way, so your duplicate picture looks like this. So you're seeing these. This is truly a cone, isn't it? Truly a cone. And so is this one be a cone because it reflects this way and it's rotating here. The only difference, I like what he did in this equation here. What did he do that you would have to do to finish this problem? You have to be aware of that. Not one person. Give you a clue. The thickness of that disk is a dy. Well, where are you going to get a dy from?
We have to solve to find the radius.
You would have to solve it for what? She says the radius, but I know what you mean. You want to clarify a little bit? Solve it for what then?
The dy.
But there's no dy in this equation. How do you solve it for dy? You're on the right track. You have to solve this equation.
For x?
There you go. Who was that?
Danielle.
Danielle, thank you. You got to solve it for x, because then the only way when you integrate something, solve for x, because that's going to be 3y over 2, I think. dy. You got to solve this for x. So x is 3y over 2. So I'm integrating 3y over 2 minus 0. There's your radius, Carolyn. Your radius, r of y, function of y, is 3y over 2. So when I integrate that, I have to square that, going from the smallest y value, 0, the largest y value, I don't know if he marked it or not. Did he? I wrote all over it. Let me erase, see if he wrote it. If he didn't, then I'm gonna have some work to do. Yep, he gave it to me. What if he didn't tell me it was a 2? What would you have had to have done? What if he didn't tell me it's a 2? you literally would have to put in the 0, the x is 0, and plug it into here. Wait, that's not going to do it. I'm sorry, the x, that x is 0. Is that going to do it? 10, no. Well, that's a 3. I thought it was a 5. Blind, but nobody said nothing to me. It's a 3. 2 times 3 is 6. 6 over 3 is 2. You'd actually have to plug that in. I actually do it like this too. If x is a 2 or 3, then what would that give me if I plug that in and solve it for the y? It should give you the 2. That's how I'd find out. These are pretty standard. This is going to be a hard one because I'm going to put a star. I'm not going to help you with it right now because you have to realize that to solve that for x, how am I going to solve that for x? Play with that before you get solutions to that, or I do it for you. How do you solve an arctangent function for x when y equals the arctangent?
Is it like
There you
first you get rid of the constant in front and then you do like tangent y?
You're just way too smart.
Well, I'm not
Yeah. Say it all one more time, and we'll let that sink into their head. Say it again.
I think you first get rid of the 4 over pi, so you multiply pi over 4, and then you do the tangent of
Both sides.
both sides, and to
Yep.
get rid of the arctan.
Yep. She said it perfectly. I'm amazed. I'm amazed. I say it because you say it like it was so easy, but I know for a fact that it's not. Okay. All right, let's move on to part 3. This is the crux of today, and there's very few problems. There's very few problems in part 3. So what I did was, I'm gonna go to the end of the lecture. It's just a few pages, a couple examples. All it is, a couple. Of course, all you need is a couple. There is the textbook homework. A lot of them are there. You need to practice those. But I added some extra ones that come from a standard test bank of all the volumes all mixed up. Or not all mixed up, but they're everything we have already done, including one extra thing. I don't know if they did the cylindrical shells. That's, yeah, I see the word. So you could not do this one right now. Not now. Because cylindrical shells is not in lesson 1. Cylindrical shells are not in lesson 1. So you can't do those two for sure. And you can't do number 9 because it also is cylindrical shells. Cylindrical shells is not on the AP exam. So typical years, I never teach it because the college let me get away with teaching everything AP-ish and just making sure that I made students accountable for the textbook material. But I don't think I ever made them do it. So there's only 7 problems that are not cylindrical shells. You notice the 1 through 7, they don't even tell you how to do it. But they have to in cylindrical shells because you don't have to use cylindrical shells to get this sometimes. You could do it a different way with what we're doing today or disk method. It usually is a replacement for washer method, but doesn't have to be. All right, back up to the beginning of it. Here goes. You ready to get out of lesson 1? Anybody? You don't care. You're like, whatever. Okay. Yeah. I don't see everybody. I don't even know if everybody's in the cloud. I can't even see everybody. I should do something to see how many of you are actually in the room. I should really be mean. I should maybe give you like a, what can I do to prove if you're all here? I could make one problem, 5 extra credit points today. Only if you are listening and you're in the room. That's what I should do. Okay, here's what you're going to do. You're going to send this through Remind at lunchtime. I don't want it before lunch. I want it during lunch. I want you to find the area between y equals 2 and y equals to x squared. Show me all the work. I'll say it one more time.
Wait, is this?
I don't talk. I don't want everybody to hear you.
Oh yeah.
I don't want everybody. I want to know who's actually. When you talk, I know everybody's gonna start listening. I'll try to make it clearer. Obviously, graph these two functions. Shade in their area. Find the area bounded by those two curves. And just take a picture of your work. And send it to me. That whole region. Okay, I'm not saying again, because this is a test to see who's actually listening. Washer method. It's still a solid, but now we're not creating a hockey puck. Those delicious candies that have a hole in them. You can't see the hole when you're looking at the Lifesaver from the side, but if you look from the top, you clearly see they've ripped you off of some candy. That's called a washer in the plumbing world. And the washer is an interesting object because the washer has, if say the radius of the whole circle is here, that would be a big radius. Then you have another radius that stops into the hole. That would be a smaller radius. So the interesting thing about the distance that we are spinning around is actually your big radius minus your little radius is actually what we're doing. Big radius minus little radius. And when we talk about the area of that circle, it's actually pi r squared minus pi little r squared. Because when this sweeps around into a region, we're sweeping it around and we're getting the whole area of a solid. We're pretending there's no hole. Sort of like if I was just doing a very simple graph like there's half a circle from -2 to 2. If it sweeps around, right? But what would have happened if there was another curve there? Here's that circle, half a circle. But I'm also going to say this horizontal line. So now you only have this is your solid. once all said and done, once it's all said and done, well, that's too big. And I'm duplicating the image down here so you can see that I've duplicated it. And what ends up happening is that thing spins around is this isn't really there. Yet you don't know it because when the outer function sweeps around the axis, when the outer function sweeps around the axis, all you see is this. But what you don't know is that there's this inner hole in there. Because as the outer function swept around and created this, the inner function sweeps around and cleans it back out. That creates every slice. Do you remember when we took a slice? Any slice will do. Let me take a slice using the yellow color. Take a slice out of that and lay it down, and it looked like a hockey puck. Still looks like a hockey puck from this side. But what you don't see is that there's a hole all the way down. And the volume of that hockey puck, when it was a solid, was just pi r squared dx, pi r squared h. But no longer can I use that because there's two radii. I do have the big radius, but then I also have the small radius. So in terms of my calculus, my volume was still going to go from -2 to 2, because that's how I made it, -2 to 2. There's still a pi, but I have a big R in terms of x squared minus the small r in terms of x squared dy. So I'm basically taking one big cylinder and subtracting the inner cylinder. One big cylinder, subtract the small cylinder. So let me see if I can get your pictures up and maximize what I can't see normally. Taking a second out of my life to do this, and I still only see a few. Let me have a thumbs up if you're somewhat understanding what I just said. Got 1, 2, 3. Okay, I got several on that page. So okay, a lot of you are. Okay, so I never know you're here. Okay, so I may have bit myself. I may have. Can't see my screen anymore because I'm looking at the back to my iPad. There's the big R, there's a little r, there's the area pi r square, big R, little, okay, it's all the same. There's your formula. Looks very similar to what I just did, except for he's got the pi on the inside. That's about the x-axis. Obviously, you could go around that is still the same formula, x-axis. So let's do this problem. Are you ready for some torture? Anybody? I got to go back and look and say, do you see any thumbs up? I don't think I would go back and look for your thumbs up again. I'm hoping that you heard me say that back. We're going to try this example. I'm sure you're all ready. You all were born ready, right? I'm missing a picture though. I thought there was a picture in their notes. Maybe, oh, there it is. I knew I missed it. There is a very good picture. See how you got the outside function, the inside. I like how they do it 3D. So you can see that you have this solid, but on the inside you have this smaller one coming through. Yeah, I knew there was a picture there. All right, number 9. Why am I at number 9 if I just started? Somebody tell me why. Because this is the same lesson. It's the same lesson we've been working on. The region is bounded by the curve, this parabola and this line. So what we first want to do, and it's rotated about the x-axis. So that's pretty standard. Let's see what it looks like, at least in 2 dimensions. There's my, oh wait, no, has to shift up 1. There it is. There's my parabola. A lot of things I noticed about your tests. Some of you aren't, you're doing work without doing any graphs. And that isn't very, it doesn't say you understand what's going on that much. I mean, it shows that somehow you have a correct integral, but where did it come from? It does make me question some of it. Where does it come from? The line, y is negative x plus 3. Okay, so y-intercept's 3 and the slope is negative 1. So there's 3. So I'm going to do that line here. So obviously I should go out farther and make sure this parabolic, okay, there's a cut. And just like before, the region is bounded by their intersection. So yeah, I'm going to have that region. I need to find where they cross. So I'm going to set those equal to each other, which we've done that before. He's given us relatively simple equations because it's x squared plus x minus 2. And that factor is easy. And it actually does give me, whoop, in the wrong place, don't I? I need to put the plus here and the minus here. That makes a big difference. Because I want a positive 1 and I want a negative 2. Okay, equal to 0. So x is a negative 2 and x is 1. So right here, negative 2, 1. All right, now that region is being spun around this x-axis. So what happens is, if I just duplicate the linear part, all you're seeing is this. Right? Just a cone. But deep down inside, how many licks does it take to get to the Tootsie Pop of a Tootsie Roll center, whatever? To get to the center of this hole is being reflected. And you know me, I'm not a good artist, so the odds of me even coming close, well, it's not too shabby. That inner hole is coming around just as well. And it's forming its own little picture in here. That may not be so bad of a picture. That may be one of my best pictures I've ever done. So there's my picture. Realizing that the line is creating just this volume from negative 2 to 1 of x squared plus 1. That's the solid. If it was completely solid, okay, that'd be the problem that we would have done last meeting. But this is my large volume. My small volume comes from that hole, which is also negative 2 to 1, but it is of the, wait, I messed up, didn't I?
Oh yeah, there's switch, right?
This one's supposed to be x squared plus 1 dx. This one's supposed to be what? X plus negative x plus 3?
Yes.
Yeah, thank you. Claudia is on fire all the time. I'm so impressed. And so this is creating me my small volume. That's that inside the blue one, the blue funnel. So there's 2 separate volumes happening. So basically what you're doing is putting them together and just saying, and I forgot my pi. And it's the same pi for both. It's the same dx for both, because when I slice out a disk, it's still the same dx for both. So I put it together as one. Volume will be integral -2 to 1 of the negative x plus 3, the outside function squared, minus the inside function x squared plus 1 squared dx. And so setting it up probably took some time, but now getting it worked out by hand is where I mess up. Negative x times negative x is x squared. Negative 3x plus negative is negative 6x. 3 times 3 is 9. I hope I squared that correctly. If I didn't, I'm going to hold you accountable because I needed your help. X squared times x squared is x to the 4th. 1 times x squared is 1x squared, double it.
Wait, sir.
Say it again.
I'm sorry, I'm just kind of confused after L5.
After what?
After the L5, I think, or I don't know.
That was
after
small.
the green.
That was small.
L small, yes. Like, why did you square them again?
Why didn't I square them?
Yes. Yes.
Brenda.
Why did he square it after L5?
I'm old and I have like senility. I did it here, but I didn't do it here
Oh no, I meant like, why did you square it?
because the volume of the cylinder is pi r squared.
Oh, okay. So you have to know that before.
Yeah.
Okay.
It was probably me that confused you because I didn't square it in there, but nobody said anything, so I kept on going. And then I did it right down here. Strange. How do you mess up one time and not the other? I can do it. Dx. This minus, I was very careful to put a parenthesis because I know that if I forget, some signs will change. Pi -2 to 1. I have negative x to the 4th. I'll put that first. I have an x squared minus 2x squared. I think that's an x squared. I have a negative 6x, and there's no x's over there, so it's negative 6x. I have a 9 minus 1. I think it's an 8. I'm going to take a breather here, and I need to hear someone confirm it or deny it.
I think it's supposed to be a negative x squared.
Yeah, you're right. I think I said it, but I didn't write it. I said x squared minus 2x squared. I don't know why I wrote my plus. I remember saying it. Thank you, Danielle. I knew. I wanted to make sure. Okay. The integration is actually pretty simple. It's just a polynomial. So it's going to be a negative x to the 5 over 5. Some of the stuff you guys did on the test, where it's like, you must have done all your adding at once or something. I don't know if you really can do that without putting all that stuff down. Well, I'm talking about when I plug in the limits, but you at least need to have, what is the antiderivative? You have to have the antiderivative. I don't know why you wouldn't write the antiderivative the way it comes out. And then I'm going from the -2 to 1. This is where it was also crazy because some of the stuff I saw just didn't make sense to anything I ever showed you. And it didn't make sense to any of the videos I sent you either. So from myself and from other people. Unfortunately, you're not going to get a 0 out of either one. So it's just going to be painstakingly ugly by hand, but we got to do it. If I plug in the 1, a 1 to the 5th is still negative, still be negative. So please, I'm going to write my number. Stop me if I'm wrong. And that's going to turn into a plus 1/3. And then, wait. Yeah. Then the 1 goes in there. That should not be plus. That should still be minus, I think. This would be a -3. This should be 8. I hope those were right. Then truthfully, I might pick up a calculator if I was doing it on my own, so I wouldn't mess up. Plug in the -2, that gets even bigger chance. So negative to the 5th power is still positive. It's going to be negative, I mean. So a negative times negative is positive. I just got to do 32 over 5, I think. And then the same thing with this -2 cubed is going to be a -8, but a positive 8/3. The -2 squared becomes positive 4. And 4 times 6 is, or I'll do 4 times 3, it's easier. So it becomes plus 12 or 4. I do it again, sorry. I should make that just cross it off, make that a 3 so I don't confuse myself. 4 positive, 12. And then
Wait, sir,
negative.
wasn't it -12?
Yes. Who was that?
Max.
Thank you, Max. -16. All right. I think at this point I would key it in the calculator because I don't want to. I think, to be honest with you, I would have keyed in the calculator probably with both of them. I might have just said, here's my function. Y1 is negative x to the 5 over 5 minus x cubed over 3 minus 3x squared plus 8x. And I would go y vars and plug in a 1 and then plug in a -2. That way I wouldn't have to. Well, I could do the first answer minus the second answer. I wouldn't even probably write all that out. You don't really have to write it all out. You set this up and you don't have to write all this out if you can use a calculator to plug in the 1 and then plug in the -2. Did anybody get an answer?
117 pi over 5.
117 pi. Did you do it all by hand? Because you kept the pi out. So she didn't key in pi. She typed all of this and got 117 over 5. Well, you had to. Did you use a calculator or by hand?
Calculator.
How'd you get it as a fraction though? 117 over 5.
Without the pi.
Yeah, but how do you know it was 117 over 5? Because if you did a calculator, wouldn't it have given you a decimal number like 2?
No, it gave me a fraction.
Oh, you have one of those calculators that automatically put it to fraction?
I guess so.
Oh, okay. What calculator are you using?
TI-84.
Oh, yeah, I guess you can set it up. There is a way. I know, I've seen it. All right. I'm going to take your word for it. Let's move on to check it. That looks good. Ooh, look at the picture he has. That looks so much better than my picture. 3D is really good. Oh, that is the answer though. Okay, let's try another one. Wonder what he's going to do to us now. Now that just the jig is up, we have some ideas of another method. This region of the parabola, y is x squared, and the line y equals 2x, is in the first quadrant, is revolved around the y-axis. Think about what that meant. Think about what that means. But first, I'm going to graph what I have. X squared looks like that. In the line y equals 2x, positive slope 2, y-intercept is 0. Looks like that. And he says in the first quadrant. He doesn't want any other part of the picture. Well, duh. There's no other part even being intersected. Well, obviously, you're not going to have more than that. And we're going to revolve this around the y-axis. So what does that mean? Somebody tell me real quick. I should not have to ask twice.
We have to solve for x.
You have to solve for x for which one? One of them or both of them?
I thought it was for both.
It is for both. So you got this one here, because there's your radius to this axis. And so that's going to be square root of y equals to x. Then you have this is my, we'll call that my big R. And then your small r is this one, small r. Both of these have a thickness of dy. So that's another clue. So then this gives me y over 2 equals to x. Big R, small r. Both in terms of y. R of y. So here goes. Volume will be pi from, I need the y values. Obviously, this one's a 0. What is this y value? And how would I get it? Same thing. Set those equal to each other. Say square root of y is equal to y over 2. And square both sides. Y is y squared over 4. Put it all on one side. Well, I'll make it y squared equals to 4y. And I'll put it all on one side. Y squared minus 4y is 0. I think I have it right. Somebody stop me if it's wrong. Nobody's saying anything. Okay, I'm going to run with it then. Factor out what's in common, a y. That leaves y minus 4 equals 0. So there's my 0. And then my y is now a 4. So there's 4. 0 to 4. Big R squared, big R squared, big R came from the parabola. So that would be square root of y squared minus small r, which was y over 2, would be y over 2 squared dy. Pi, 0 to 4. Square that is y. That becomes minus y squared over 4 dy. Integrate both pieces. There's a pi. That's a y squared over 2. Minus this is a y cubed over 12. From 0 to 4. The good news, 0 is going to make it go away. So all I care about is the 4. This is actually easier than the last one. Pi, 4 squared is 16. 16 over 2 is 8. 4 cubed is 16 over 64 over 12. And technically on an AP exam, you could stop right now. That is the answer. It's just not simplified. And on the AP test, time is money. So I would stop, but pi, and this becomes 80, 16, 896 minus 64 over 12. I'm doing it by hand. You had a calculator. Pi 32 over 12. Yes, I think so. 32 over 12. No one's saying nothing to me. I'll cut them both in half. 16 out of 6 pi, which is 8 out of 3 pi. And anybody going to agree with me or not?
I agree.
Thank you. And the only thing I didn't do, I got lazy. I didn't draw my picture to show you that you had this outer piece coming out, making this pretty bowl. It's a beautiful bowl. But then you had another lathe, a knife inside, cutting it out. So it was creating this, a wonderful guacamole bowl. That would have been a nice present for your parents. Or if you're Hawaiian, for poi. Or hummus if you're Middle Eastern. Oh, I could eat all that right now. Hummus and poi and guacamole. Mm. Looking good. Answer. All right, and that's it. These were probably a couple extra problems. Yes, because the homework starts there. Let's do them together, please. We're ahead of schedule. I guess I should have crammed all this in the other 2 sessions I had. Anybody think I could have? Let's just do these 2. Let's see if we agree. You guys got to do them with me, guys. And there's like 3 of you out there for sure I know are doing it with me. How do I know? They caught my mistakes. The volumes of solids generated by revolving the shaded regions of 39 and 40 about the indicated axes. So I gave you one of each, an X and a Y. So this picture is already graphed for us, and it's spinning around here. So you need to realize that this creates my big R in terms of X. This creates my small r in terms of X. The picture is very deceptive because when it spins, all you see is this cylinder. You see like a Coke can. That's all you see. Little do you know that if they made a Coke can out of this thing, they'd be ripping you off of some valuable product because you have this thing coming around and it cuts out. So it's not a full Coke can. It's somewhat like this. There, that's better. It looks like a full Coke can, but it's not, because you have this air in the middle that goes around too. See? So let's do it. Volume is pi. X, smallest x I'm doing is negative pi over 2 to pi over 2. And the function of the top function, somebody tell me what's the top function? What's big R?
1.
1. 1 squared minus. What is small r? It's this thing here. It's a cosine graph. Wow. Cosine of x squared. To make my work easier, do you think it's symmetrical? Cut at 0? I think
Yes.
it is. I'm just going to go from 0 to pi over 2. 0 to pi over 2 should give me half the can, as long as I remember to multiply that answer by 2. 1 squared is 1. And cosines, oh no. This is a hard thing to graph.
I'm sorry.
Yes.
Isn't it the square root of cosine?
Oh, I didn't see that. And you know what? It's so good that you saw it, because most of you probably don't remember how to graph the cosine squared. It was the 1, I think it was 1 plus sine of 2x, or I think that's what it was. If it wasn't, thank you though, you made it easier, because if I square a square root, it just becomes that. Thank you, Danielle. See, it's not that I don't know what I'm doing. I got blind. I really am blind. And so that's 2 pi times an x minus, what's the integral of cosine? Should have said that fast. The derivative of sine is cosine, so the integral of cosine is sine.
Wait, sir, isn't it like cosine is negative sine, or is it the other way around?
The derivative of sine is cosine, And that's what I had here. I had a cosine.
Yes,
If
but then isn't the derivative of cosine negative sign?
Yes, the derivative of cosine is a negative sign. So if I would have had a negative sign here, or if I would have sine here, I would have to say negative cosine. You're
Oh,
absolutely
wait.
right.
Okay, wait, we're doing the antiderivative, right?
Yes,
Okay, I'm sorry. Yeah, I got confused. Thank you.
that's okay. I get it confused all the time. There's no shame in that. This is close to rocket science, so you have a right to. I do too, guys. Same questions. Sometimes I go, why? Oh yeah. And I'm old, and I've done this stuff 100 times, and I still have to question myself. Like for instance, I'm not even 100% for sure it's a plus here. Could be a minus. I don't remember. I have that chart I gave you guys, and I have a whole bunch of charts that I could just make a notebook out of. Let's plug in pi over 2. So it's 2 pi over 2, and sine of pi over 2, the 90 degree, isn't that a 1? I hope it is, or I just messed up. Minus a 0 minus sine of 0. And I already was thinking that was going to give me a 0. I wasn't 100% for sure, but sine of 0 is 0. So I don't need anything I wrote in black there. So 2 pi times, I'll put a little 2 here. That stands for 2 pi minus 2 over 4. That's 2 pi times, well, that didn't help much, did it? 2 pi minus 2 all over 4. It's not, it still has to be distributed. I may as well have left it the way it was. I may as well have left it as times pi over 2 minus the 1. It's going to give me the same answer. 2 pi times pi over 2 is 4 pi over 2 minus 2 pi. What's wrong with that answer? I don't think there's nothing wrong with it, except probably if you multiply that by 2 over 2, that gives you 4 pi minus 4 pi. That's 0. Can't be 0. Something's wrong. Help me, somebody.
Where did you get the 1/2 from?
I don't know. Let me do it again. Oh, wait, maybe that was on. It was not, it was supposed to be, where did I get the 1/2 from? Oh, I plugged in the pi over 2. Then yeah, that's what I did. Okay, let me just back up. Is that what you're saying? From there on, I'm wrong? Of course, we know that's not right. Can't get a volume of 0. I'm just going to go see what I did. I'll have faith that she knows I did something wrong. Maybe we can't see it. We do it slower. 2 pi. Oh, I don't know what I wrote. It's pi over 2. Oh, I know where I got it from. I may have lost the pi. Minus 1. That's it. And then the 0 did give me 0. I have faith that sine of 0 is 0 and 0. Okay. Are my limits correct? Oh. Are my limits correct? I think so. I think it is 0 to pi over 2. Go ahead, somebody. Save me. You see something else. Why does it look like my answer should work? 2 pi times, 2 pi times pi is 2 pi squared over 2 minus 2 pi. That's what happened. I don't think I squared something. If you're on the AP test, though, stop right here. Don't do anything dumb. Let's see. Multiply by 2 over 2. That's what I did. I forgot to square pi. I found my own mistake. That's 2 pi squared minus 4 pi all over 2. which turns into simpler pi minus 2 pi. I'm sticking with that answer. Somebody wants to integrate this with a calculator and tell me if we get the same answer? Is that this is the actual answer? And then you would not have the actual answer unless you, oh no, if you just left the 2 pi out, this is the answer you should get, which would have been 2 pi times pi minus 2 over 2, whatever that is as a decimal. So somebody check out their decimal and see if they get that as a decimal. And if you're not, no one's going to check it, then I'll move on to number 40. This one is revolving around the y-axis. So here is your big R. Here is your little r. Your little r is the one that usually is creating a volume of air. A volume of air. Look at it. It's air. There's nothing in there. It's air. Okay. So I'm going from 0 to pi over 4 because he already wrote it in. So volume is pi of 0 to pi over 4. Big R is x equals to 1 is my big R. My little r, they were so nice enough that they already solved it, is tangent of x. Thank you, author, for doing that. Big R was 1 squared minus tangent of x squared. No, tangent of y squared. And it's a dy because each of these discs have a dy for a width. So if I take that one out, the solid is a dy, the air is a dy. All right, is pi times 1 squared is 1, so it gives me just a y minus, what's the derivative of tangent squared? I'm sorry, what's the integral of tangent squared? What I was going to say is tangent, the derivative of what is tangent squared? You need to have it quicker than that. And if you don't know, I ask myself, what's the derivative of secant? Secant is secant tangent. What's the derivative of tangent? What's the derivative of tangent? Isn't that secant squared? Yes, no?
Yes.
And so I have a tangent squared. That's neither one of those. So what are you going to have to do? We don't know a tangent. We don't know what gets a tangent squared. Could you change that to an identity? Is there an identity for tangent squared? I'll just call it x this time just because. Is there an identity? Is what I'd be doing. I know that sine squared x plus cosine squared x equals to 1. If I'm looking for tangent, I'll divide everything by a cosine squared. Nope, that won't work. Well, that's going to take away this wrong one then. Let's see. Sine squared plus divided by cosine squared divided by cosine squared. That gives me 1 plus, what's cosine over cosine? That is tangent squared. I'm sorry, tangent squared of x plus 1 equals secant squared. My identity for tangent squared, which who knew you had to ever do this again, is secant squared x minus 1. That's the conversion I'm going to have to do. No one told you everything's going to be easy. So that turns into pi. I should have left it before I did the work, pi over 4, 1 minus this. So that gives me a minus 1. That gives me a plus 1 and a minus secant squared. So you're really integrating. And I should have looked ahead and I didn't. A 2 minus secant squared y. Well, who would have thought that would be an issue? But I can do that integral. I could not do this integral. So I said, now I know what's derivative of what is secant squared. I wrote it up there. Derivative of what is secant squared? Tangent. So my answer now is not 1y, it's a 2y minus a tangent of x, of y, from 0 to pi over 4 is pi times 2 times pi over 4, which is pi over 2, minus tangent of pi over 4, which I think that's a 1. I'll come back to it, minus a 0 minus tangent of 0. And I think tangent of 0 is a 1. No, it's not. It's a 0, isn't it? Okay, nobody wants to talk to me. Pi times pi over 2. Tangent of a 45-degree angle is a 1. And tangent of 0 is 0. So I don't care about any of those other numbers. There's my answer. Whatever that is. There's the exact answer. It may not be the decimal that you'd want. If you give decimals, 3 decimal places. Nobody has a question, comment? Nobody's going to agree with me or disagree on those problems? Come on, don't make Danielle always catch where I didn't do something. There's your part 3. So all your part, this is part 3, all your part 6.1s, part 1, 2, and 3 is what will be due on Friday. Today is Tuesday. Well, you're lucky. Usually whatever I do on Thursday is not on the end of the week because A day is that B day doesn't get it till Friday. Well, I think the only thing you had, anybody remember when that con is due? Is it due today or is it due tomorrow?